Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's program because, some cool things have happened this week. Some not so cool things, if you can say that, have happened this week. But ladies and gentlemen, today we got some really great stuff, and this is all thanks to the one, the only Mr. Ralph Bond. He is our science and tech trends correspondent, and he'll be joining us here in just a moment to talk about 4 different stories, and they're all going to be really fun. And if you want to follow along, computeramerica.com, that's where you'll find our past shows, future shows, show notes, articles, all that and more. Everything that we do here at Computer America, you can find on our website. And of course, at the top, you can find Ralph and a whole section of the website dedicated just to Ralph and his past shows and show notes. So we'll talk about the show notes. We'll talk about what the general thrust of this whole segment is. But suffice to say, you're probably going to learn something because we cover news all week, and none of these really end up in our day-to-day feed, and that's okay. Sometimes you want to hear, about the latest Samsung phone, and sometimes you want to hear about the next revolution in air travel, for instance. So different shows for different folks. So with that being said, once again, computeramerica.com, let's go ahead and bring Ralph on. And if you can't tell, I've already finished my first coffee. It's going well. So everyone, welcome back onto the program, Mr. Ralph Bond. Ralph, how you been?
I'm doing great. And talking about coffee, of course, I have my famous gigantic, I don't know if you can see it on the video.
There it is.
Part of it is kind of breaking up, this gigantic mug of coffee. This is what keeps me going every day.
Absolutely. So I hope that you're doing well and,
yes.
Gave a little bit of an intro. Let's just go ahead and give the nice folks, if it's their first time tuning in, a little bit about our segment.
Yes. So what Ben and I do each Friday is look at where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, advances in physics, and you name it across the board, folks. If you're looking for ending your week feeling good, feeling uplifted by where we're going in science and technology, that's what we do with our trends segment. Most of these stories are things that are early research. Some things are deliverable today you may not have heard about, but I guarantee you will feel good about being a human being and the future we may have if we just let our scientists and technologists march forward.
Definitely. And before we get started with the 4 stories, exactly, we were talking, just lightly about it before the show, but just yesterday, the Intuitive Machines IM-1 lander, called Odysseus, or Odie for short, landed on the moon's surface. So, hey, this is the only sound effect I have kind of loaded up. So, a little bit triumphant, but yeah, no, it was really good and really, really cool to see. Yes. I mean, first time in 50 years, as everyone keeps saying, that NASA's back on the moon.
Yeah, it is just hard to believe. And one of my because I'm an old guy, one of my teenage memories is when we first, put people on the moon, and one step for man, giant leap for mankind, huddling around our black and white TV, watching that, just going nuts. And so this is so great to be back on the moon.
and it's so, like, obviously space has become, just, I think it was like this week or last week, it kind of scared us all to think that space may be the next, kind of a war zone. But, Rob, it goes to show that, like, the Mars rovers. We're sending probes to the moons of Saturn. We have one that's exited outside our immediate solar system. Like, we have a lot of space stuff going on. It kind of goes to show, Ralph, that the moon landing was like the most watched, and even to this day is still like the most watched thing. Like, that was the television program. I think the Super Bowl, this Super Bowl that just happened was like the second most watched television event in history. The first being the moon landing. Now we just went back to the moon again, and it barely makes like second story front page. It's cool. People like it, but it goes to show just how kind of routine I think people think these missions are.
Yeah. No, you're absolutely right. It's just amazing.
Yep, for sure. So with that being said, congratulations to all them, and always love when science and tech kind of meet like that. But hey, we have different science and tech news, and if you're watching the video portion, you can see it there. You can follow along, or if you are simply listening and you want to get more information about this later, the show notes over at the website will have everything that we talk about. So with that being said, Ralph, let's go ahead and get started with story number 1.
Yeah, this comes from The Cool Down, a very interesting source. And the headline here is, the company Bill Gates just backed is aiming to revolutionize air travel with a surprising resource. This all has to do with sustainable airplane or aircraft fuel. And that's been a whole area you and I've talked about many times before, with other technologies, other efforts, and so forth, to create alternatives to fossil fuel-based jet fuel. And this is going to involve a company called Viridose. That's Viridos. They have a great website, but let's get into the story here and explain what's going on. So, of course, we all know the need to revolutionize the air travel industry is clear, as aviation accounts for 2.5% of all global planet overheating pollution. And this was interesting. And passenger air travel represents the highest amount of pollution per individual user of any industry. I knew aviation was an issue, but that's kind of a shocking, especially when we're about to fly the family to Hawaii again in a couple of months. Oh gosh,
I had always thought that, and I knew that the planes were the fastest, but I didn't think they were that inefficient, compared to like cars and stuff. That's crazy.
Yeah, that is pretty frightening. Yeah, you're right about when you take a plane that might have several hundred people on it and you divide it up in terms of pollution output, to know that it's the highest amount of pollution per individual.
It's the contrails. It's the contrails, for sure.
Yes, those are a problem. We've talked about that too. Okay, so one startup company is seeking to change that, and it recently received a substantial investment from Microsoft founder Bill Gates to help in its mission. And that's the company I mentioned before, Viridose, Viridos, a California-based company that was founded in 2011, focuses on turning microalgae into biofuel. The company hopes that its products can eventually become dense and energy intensive enough to power airplanes and even ocean vessels. So this is a good example of a trend story, Ben, because they hope eventually to get this technology to create fuel that can be used for aircraft and ocean-going vessels. They're not quite there yet. So that's a good example of this trend focus that you and I take each Friday. So a little side note, what are microalgae? Well, microalgae are microscopic algae invisible to the naked eye. They are phytoplankton, typically found in freshwater and marine systems, living in both the water column, as it's called, and the sediment of the bodies of water. And they are unicellular species which exist individually, or they can be formed in chains or groups. And in the show notes, folks, if you can come out to computeramerica.com, as Ben mentioned, get the show notes. We have the links, we have pictures and so forth. But in the show notes, I have a little microscope picture of a microalgae colony of individual little unicellular bodies. So Viridose has developed if I could say it on Friday, they've developed a proprietary process that combines sunlight and carbon dioxide to produce microalgae, which is then converted into biofuel. This gives the company an advantage over other biofuel fuel makers that rely on ethanol from corn or soy-based biodiesel. So the point they're making is most everybody else is trying to do this with ethanol or with biodiesel from soy. And that's not bad, but it has an impact. Instead of competing for crops that are part of the food supply, Viridose can simply generate its own material with minimal fresh water, and you'll find out salt water as well, and no farmland required. Ding. So they're not taking crops away from the food chain. They're not messing around with active farmland, unlike other competing attempts. And then the Viridose website, I shifted from the story in the magazine over to their website to pick up a few more things, which I thought is very, very interesting. We believe, this is what they said on their website, we believe that high energy density algae biofuel for heavy transportation is part of the answer for, of course, global warming. Mm-hmm. And by establishing this non-resource intensive breakthrough solution deployed at global scale, we can recalibrate heavy transportation toward a more sustainable future. Wow. There's some great images. Oh, you're showing a good one here on the screen right now. Folks, if you're listening to us as a podcast, come out and check out the video. That would be good. Showing one of their experimental algae farms.
Yeah, it's the,
you can see what it looks like.
It's the California Advanced Algal Facility. So CAFF.
Yes, that's right.
Yeah. And I guess like the part about algae that's so cool is that, you know, algae is like, I not to brag, folks, don't get me wrong, but like growing up in Florida, everyone had a pool in our neighborhood. Growing up with a pool, you can't stop algae. Like algae just like you put in chlorine, bromine, you put in like so many chemicals, you know, acid, whatever for pH levels anyways. But like you try to get this stuff to not grow, Ralph, and it wants to grow. So being able to turn something that's just, you know, kind of gonna happen anyways and turning it into, you know, and admittedly, this is like a special algae, but it makes so much sense and cool that you can kind of turn it into oil.
Oh, yeah, absolutely. And here in the Northwest, I'm outside of the Portland, Oregon area, folks. Our nemesis is moss. Moss on our rooftops, on our sidewalks, on our driveways, almost everywhere. And that stuff, to your point, like microalgae, unstoppable.
Yeah.
But anyway, going on from the website here, it says, we are developing an advanced microalgae strain and agronomic platform to produce biofuels for deployment at scale, meaning their goal is to get this ramped up to a meaningful scale. Yeah.
Yeah. And this has, this is part of their website to kind of show this. And for those who are just listening, like they have other crops such as corn, ethanol, soy, biodiesel, palm biodiesel. And then they have theirs, which shows much more yield, but obviously this is not up to the production level of corn by any means, because, you know, we have like entire state, like we have Nebraska, the entire state of Nebraska is just corn. There's 0 people, 100% corn. And I guess that's what they're kind of getting at, Ralph, is that, you know, if this were on the scale of soybean production, corn production, whatever, it'd be so much more efficient.
Oh, yeah, absolutely. And again, I want to stress their point, and probably why Mr. Gates was interested in them, is they're not competing against food production sources. They're going after something completely separate from that in the form of microalgae.
Stupid me. And I was like, you know, what part of corn turns into ethanol? Like, is it like the stalks that they, you know, kind of grind up and, you know, do something to? But no, it's actually the corn kernel. It's the part that we eat.
That's right.
You know, that I guess that's where all the sugar is, and that sugar gets, you know, metabolized into ethanol and blah, blah, blah. So, you know, that's way more food production.
Yeah, exactly. And then back to the website, they're talking about part of what they think will make this happen for them is all of the official programs that encourage the production of sustainable aircraft fuel, or SAF as it's called in the industry. So they say by capitalizing on well-established regulatory programs that incentivize adoption, such as the Environmental Protection Agency's Renewable Fuel Standard Program and California's Low Carbon Fuel Standard in the United States, and the Renewable Energy Directive in Europe, we can make the adoption of microalgae biofuels more attractive and establish a more level playing field, meaning compete against the crop plant, the corn and palm and other alternatives. Right. And then they go on to say, microalgae are excellent at converting CO2 and sunlight into oil-rich biomass, especially when compared to land-based crops like oil palm or soy, or corn. And by adapting microalgae to function as cell factories, I love that, cell factories. By adapting microalgae to function as cell factories producing energy-dense oils that can easily be refined into renewable diesel and jet fuel, we can reduce greenhouse emissions by 70%. Now, that statistic, I think what they mean is not overall greenhouse, but in that industry segment. That has to be my guess on what they mean by 70%. Otherwise, that would be a little too aggressive. And they go on to say, by farming in salt water on marginal land, we avoid competing with resources required for food production, such as arable farmland and fresh water. So again, that sort of amplifies what we were saying earlier. And finally, we estimate that at commercialization, meaning getting it to a scale that makes sense and is economically viable. So we estimate that at commercialization, the productivity of engineered microalgae will be 20 times greater than any existing terrestrial crop. This dramatic advantage underpins the scalability of our technology. Folks, go out and check out Viridose. Very interesting. I can certainly see why Mr. Gates is putting his money behind these folks. Very interesting development.
They certainly seem farther along than some of the other companies and projects that we talk about on the show. Right. I am curious, kind of what happens, because it seems like they're mixing it just like ethanol, where it's 90% gasoline, 10% ethanol, and then this would be kind of a mixture with diesel fuel. So it's not completely, batteries and electricity and solar energy, so on and so forth. But it takes, I'm sure, a large chunk of it, like you said, 70% reduction in, kind of those emissions. So it may not be, the 100% elimination of it, but it's something. Because I was kind of wondering, Ralph, what happens when you burn this biofuel? And I'm guessing it's the same thing that happens when you burn normal fuel. It's just the production of it is much more efficient and, makes it much more, I guess, like the equation, the input to the output, much more equal, I would guess.
Yeah. And Ben, to your point too, I would have to assume, I don't know right offhand, I'd have to go and dig deeper into this a little bit here. But my guess is when this kind of fuel, this microalgae biomass oil-based fuel, whether it's mixed in with existing fossil fuels or independent and exclusively, would have to burn cleaner than the traditional fossil fuel based only. I would have to imagine that's how they're going to try to achieve this 70% reduction in that industry segment.
Well, anyone out there wants to go do the research for us, let us know.
Please do.
Ben at Computer America. And of course, the show notes. Hey, all the links are there. Just a little bit more for you. There's always more to these stories than what we cover. But Ralph, good job on story number 1. Story number 2, let's face it, AI is pretty cool. I think a lot of people have said that, but I think there's still new ways that, we're kind of like a new technology and everyone's figuring out how do we use this. But of course, there's some people that are like, that's not good enough. We have to figure out what's next for that technology. Even when it's like brand spanking new, like it is shiny and new, people, Ralph, still have to say, what's next? And those are the people that we depend on. So I think story number 2 is one of those folks.
It sure is. This comes from SciTechDaily, a great outlet. And actually, its source of the information is the University of Pennsylvania. We'll learn more about that. This story, before I read the headline, just makes my brain explode because it's so potentially profound and such a complete shift in the whole world of chips and computer chips and so on and so forth. So here's the headline, finally. At the speed of light, unveiling the chip that's reimagining artificial intelligence processing. So there's a lot to unpackage here. So here we go, or unwrap. And we've got a video, so forth in the show notes, but here we go. University of Pennsylvania engineers have developed a new chip, get ready, that uses light waves rather than electricity to perform the complex math essential for training artificial intelligence systems. The chip has the potential to radically accelerate the processing speed of computers while also reducing their energy consumption. Maybe this is as profound potentially as...
Oh, Ralph, you there? We may have lost Ralph just for a minute, so hopefully he'll be back in just a second. Connection issues. You can't predict them. So, for those who are just tuning in and who may have caught us at just the wrong time, you of course have story number 2, At the Speed of Light, Unveiling Chips That Reimagine the AI Process. And it looks like Ralph did indeed. Wait, no. Was it Ralph or was it me? It was me. Well, that's embarrassing. Yep. And by me, I mean Zoom. So we're going to try to get that back up and running. Although it's looking like it might be the internet altogether. So I apologize, folks. We've been having some... perfect. Right in the middle of it. We've been having some internet problems and connectivity in the past day or two. So hopefully this clears up really quick and we don't have to do much. So everyone just stand by. Computer America will be right back here, hopefully in just like a couple of seconds. For those who want to learn more, computeramerica.com. Once again, we'll have all the shows. Past show, I know that we kind of theorize some stuff, and if you want to, do our homework for us, you can go ahead and do that and send an email in. So for all those out there who are, kind of just listening, let's go ahead and talk a bit more about story number 2, and hopefully when Ralph joins us, he can kind of pick up where I leave off. But University of Pennsylvania engineers have developed a new chip that uses light to, let's put that there, uses light waves rather than electricity because, at the speed of light, I always thought electrons essentially travel at the speed of light. But no, they're using light waves to perform the complex math essential for training AI. The chip has the potential to radically accelerate the process speed of computers while also reducing their energy consumption. So, there you go. With that being said, the silicon photonic chip design is the first to bring together University of Pennsylvania professor Nader, and I apologize, Ngata's pioneering research in manipulating the materials at the nanoscale to perform mathematic computation using light, the fastest possible means of communication. Obviously, you can't get much faster than light, with the silicon photonic platform that uses silicon, the cheap, abundant element used in mass production of computer chips. So there you go. Everyone will be right back. Actually, oh yeah, we're back. Perfect. So let me go ahead and get this back up and running. Hopefully we can just jump right back in with Ralph. We should be back up and running. Just one moment. I apologize for this. Yeah, we're back up. Okay, so let's see. And I apologize for that. I don't know why that happens. Very, very problematic. So hang tight 1 second as we go ahead, and that's back open. And let's see. Oh, live production. It's always so fun. 1 moment. Yep. All right, folks, we're going to ignore this, and we might actually cut all this out, but if we don't, then there you go. Okay, we have Ralph back. Again, everyone, apologize for that. The internet is not supposed to do that, but hey, you can't plan for these things. Ralph, welcome back. How you doing?
I'm back. Where did all of a sudden I realized we were disconnected.
Yeah, I apologize. That's totally on our end. Our internet provider decided that we needed a little break. So,
oh gosh.
Yeah.
Oh, I hate that.
Yeah. So thanks to them for that. But we're going to
do that kind of stuff at 3 a.m. in the morning, people.
Yeah, tell that to all the customers of AT&T. See how they feel.
Yeah.
Yeah. But so everyone, again, I apologize, Ralph. I took the liberty of reading over some of your notes. So everyone out there who has been listening to me kind of ramble and stumble through this, but Ralph, let's just say that I left off with I just finished the silicon photonic chip design, so point number 2, and then we're about to get into your side notes. So I didn't get too far ahead of you. I tried to, kind of fill the time there.
Great.
But let's go ahead and pick up on the side note.
Yeah, so which side note are we talking about?
That would be story number 2, and of course you have your University of Pennsylvania silicon photonic chip, and then the side note of Nader Ngeta.
About his background.
Yeah,
right.
Exactly.
Who he is. Yes, and again, so let's pick up from there. You can read more in the show notes about this amazing man and his background, fascinating background. He's a key scientist at the University of Pennsylvania and a key driver of this amazing light-based computing technology aimed initially at helping AI systems learn. So let's pick up on that.
Sure.
And going right on after that, and again, stop me if you've already covered this, Ben.
No, you're good.
It talks about the interaction of light waves with matter represents one possible avenue for developing computers that supersede the limitations of today's chips. And this is so true, having spent so many years with Intel Corporation. This really resonates with me. It goes on to say, which are essentially based on the same principles as chips from the earliest days of computing revolution in the 1960s. So we haven't had that much of a change, essentially. It's just miniaturizing, Moore's law, on and on and on. But this is a completely radical departure, saying, wait a minute, no, not electricity. Let's do computations with light waves. What? How could that even be? But in a paper published February 16 in Nature Photonics, in Gita's group, together with Firuz Aflatooni, associate professor in electrical systems and engineering, describes the development of the new chip. And there's a quote here. They say, we decided to join forces, says Ngata, leveraging the fact that Aflatooni's research group has pioneered nanoscale silicon devices. Wow. There's a nice little picture of him in the show notes as well. Mm-hmm. Their goal was to develop a platform for performing what is known as vector matrix multiplication. If you want to geek out, click the link in my show notes for that and learn all about what vector matrix multiplication is. Well, it's a core mathematical operation in the development and function of neural networks, the computer architecture, that powers today's artificial intelligence tools. And neural networking, in a simplest form, is imitating how our brain works. Now, here's the part that just blows me away. Instead of using a silicon wafer of uniform height, flat, explains Ngita, you make the silicon thinner, say 150 nanometers, but only in specific regions. Those variations in height, so think of something that's like a staircase, up and down, up and down, up and down over the silicon base or platform. So those variations in height, without the addition of any other materials, and get ready for this, this is so astounding, provide a means of controlling the propagation of light through the chip, since the variations in height can be distributed to cause light to scatter in specific patterns, allowing the chip to perform mathematical calculations at the speed of light. It's so simple and so mind-blowing in some respects, and how they figured out how to make these variations of the surface such that when light is going through it, it scatters in patterns that then can be translated into calculating mathematical Ben,
I can imagine the sensors needed to kind of measure, just the tiniest deviations in the light change.
Yes.
Ralph, and like they said, they haven't really changed much since the 1960s, but like this is definitely a product of new technology enabling this.
Yeah.
Like this seems very cutting edge.
Oh, yeah. And this is very cutting edge. And you might think, okay, Ralph, just like most of your stories, we're talking about something that's 10 years, 15 years away from becoming a reality and implemented, I should say, in the real world. Well, in this case, not only is it a mind-blowing breakthrough, which I think even the mainstream press should have picked up on, but get this, their design is ready for commercial applications and could potentially be adapted for use in graphics processing units, better known as GPUs, which play a key role. Think of it, NVIDIA's, their stock just went this week because they showed such great earnings. Why? Because NVIDIA is a huge, probably the biggest beast on earth when it comes to GPUs, which are used in artificial intelligence systems, right? Mm-hmm. So the demand for GPUs has skyrocketed with a widespread interest in developing new AI systems. And what the research team said is they can adopt, meaning the industry like NVIDIA and others, they can adopt silicon photonics platform, light-based computing, as add-ons, says Alfaltuni, and then you could speed up training and classification relative to, again, machine learning on AI systems.
So it's just like an additional layer of computation you can put into the chip. So that's cool.
Yeah. Isn't that something? And then here is something that's sort of like, there's more. It gets even better. Check this out. In addition to faster speed and less energy consumption, Ngita and Alfaltuni's chip has privacy advantages. This part I don't fully understand. Because many computations can happen simultaneously, there will be no need to store sensitive information in a computer's working memory, rendering a future computer powered by such technology virtually unhackable. And a quote here, "No one can hack into a non-existing memory to access your information," says Alfaltuni. Wow.
So that part I kind of take to mean, like, obviously computers have RAM. RAM is where you store, kind of quick computations that then they kind of put together and, the computer can access it. So Ralph, I guess what they're saying is if you can do it in parallel instead of in sequence, you don't have to store, kind of the outputs and then put them all together at the end. They just happen simultaneously and you're good to go. So it never gets committed to memory. And, that was I want to say the Afterburn computer vulnerability that, kind of made ladies and gentlemen out there, if you tried to upgrade to Windows 10, or I should say Windows 11, and it said that your computer was not compatible with Windows 11, it was because of, it was because of Afterburn and Ghost, I think, were the two vulnerabilities where you could read memory outside the protections of the operating system. So, Ralph, I mean, security is a big issue, and I'm glad that they kind of touched on it, because I think a lot of times they kind of say, oh, security will happen when security happens. That's not our problem. But no, it's just another added side effect to a very promising technology. So I like that a lot.
Great story and a
Definitely.
Real blockbuster. Huge breakthrough.
Definitely. And hey, another way that NVIDIA can make even more money, even better. Perfect.
Sure. And Intel too. Intel's really making a push. Pat Gelsinger and crew are really pushing hard into the AI space as well.
And I've been telling a lot of people, like, Intel's kind of fallen out of the headlines when it comes to, kind of this whole thing, but when Pat came onto the scene and he decided that Intel was going to be an innovator in, innovation technology. And, he kind of made those investments at this point, 3 or 4 years ago. They're going to start popping up. And I look forward to seeing what's next for Intel, because looks promising. So either way, story number 2, I believe. And now we're moving on to story number 3, which, as anyone can tell you, finally a way to get a bit more brain tissue in here, because I have been lacking ever since Craig left. It's just been a downward slope. So let's go ahead and talk about story number 3.
Yes, story number 3 comes from Live Science, great outlet, of course. The headline is intriguing, but it doesn't really nail the super profoundness of this. But the headline is 3D printed human brain tissue works like the real thing. And that's very profound, but there's really more to it. Of course, in the show notes, we have a link. And another source that I looked at for this story too is Futurism.com. There's a great one here. And there's also a video in the show notes you can watch as well that talks about this breakthrough. So, for the first time, scientists at the University of Wisconsin-Madison have generated functional human brain tissue using a 3D printer. Functional human brain tissue using a 3D printer for the first time. That should have been the headline. Anyway, scientists printed the tissue to be less than 0.01 inch or 0.02 centimeters thick, and it contains both nerve cells and supporting cells called glia. I hope I'm saying that right. Glia, it's simply spelled Glia. All of these cells can communicate with one another and form networks. What? As they would in a real human brain. Now, a little side note about the glia. They are connective tissue of the nervous system consisting of several different types of cells associated with neurons. So that's what we're talking about here. And the tissue was created using a biological printer that churned out stem cell-laden gel in horizontal layers. Think of it like a human brain 3D printed lasagna.
Brain lasagna, delicious.
There you go. The stem cells were then coaxed to become brain cells with chemicals that stimulate this development. There's a heck of a lot more going on. We're just giving you the highlights. So come out to the show notes if you want to geek out and dig in deeper. The tissue layers were carefully stacked one by one on a lab dish to form a complete tissue model. Wow. The researchers behind this work the researchers behind the printed tissue described their accomplishment in a paper published February the 1st, not too long ago, in the journal. I love the name of this journal. It's sort of funny. Cell Stem Cell. Okay. Anyway, there's a link to that paper. They hope it will complement other models of the human brain, such as models crafted from actual human cells, to more accurately represent the intricate and unique features of the human brain than traditional animal models do. So that's the underpinning goal of what's going behind this research or this effort. And these include so-called brain-on-chip technologies, which mimic brain tissue on credit card-sized devices, and cerebral organoids, which are miniature simplified models of brains that self-assemble in dishes. So they're, at this point in the article, they're talking about how this research, this breakthrough, relates to previous work and existing work in this area of trying to create brain tissue, human brain tissue. And it goes on to say, to contrast this with the organoids effort, however, unlike organoids, the University of Wisconsin-Madison 3D printing technique gives scientists more control over the cells where they end up, where in the final tissue. So it gives them more control. Nerves within the printed tissue also form connections with each other within 2 to 5 weeks, a process that can take many months in organoids. In other words, this 3D printed brain tissue that these folks at the University of Wisconsin-Madison came up with can pull off something in 2 to 5 weeks that with organoids, which is probably the lead promising technique today, that takes many months. So they've contracted the time scale way, way down.
Big improvement.
Side note. Yeah, so a little side note here. I always have to go out and kind of add a little value to these articles, I hope. Side note, more on organoids. Well, an organoid is a miniaturized and simplified version of an organ produced in vitro in 3 dimensions that mimics the key functional, structural, and biological complexity of the organ in question. So that's what organoids are. Now, thanks to this speed, again, we're talking about nerves within the printed tissue also form connections with each other within 2 to 5 weeks. So thanks to that speed, different versions of the 3D printed brain tissue can also be made much more easily than when using organoids. As a result, this technology could therefore be particularly useful for testing new drug candidates for diseases that affect brain function, such as neurodegenerative and psychiatric disorders. That's because the different printed models could be made to display characteristics of each disorder. There's the real ding. What are you going to do with this thing? Are you going to, 3D print lasagna brains and put them back in my head to help me out? No, they're going to be used, as I understand it from this article, used for medical research. How wonderful. Because the different printed models could be made to display characteristics of each disorder, whether it's neurodegenerative or psychiatric. Let that sink in. Another wow.
It makes sense that they're not going to do like a brain graph. I guess is what kind of first came to my mind. But no, research is such a good, because I guess before this, no one's going to kind of reach into their own brain and kind of pull out a chunk to kind of test on it. They're going to have to find candidates who are experiencing these things or so on and so forth. Like, Ralph, I guess if you can print like a healthy brain, if you can find a way to recreate like a dementia or Alzheimer kind of type brain tissue, and be able to test on those, you could carry out so many more tests than having to wait for an unfortunate donor to kind of give you some brain tissue.
Yeah, no, you're right on target.
Makes so
and that's
much
why
sense.
I love this story. It's another great advance for research potentially. And a little more details here. We'll go through this pretty quick here. Unlike traditional 3D printing approaches, which stack layers of material vertically, the authors stacked their gel horizontally. This allowed the layers to be thinner, and thus the cells within them were exposed to as much oxygen and nutrients as possible. Because never forget this, folks, when you lab create organs, if you will, you got to feed them. You got to give them oxygen and nutrients. That's a big, big, big challenge. The printed stem cells developed into full-fledged neurons and glia, which formed networks resembling those found in the human brain. And they even communicated with each other via chemical messengers called neurotransmitters. This is such heady stuff. Believe me, I don't fully understand it, but it's just mind-blowing. And finally here, the printed cells that normally belong to different parts of the brain, such as the outer layer or cortex and the striatum, which is involved in decision-making, also formed connections with one another. I rest my case in the category of awestruck.
It is such a good development. I mean, even if it's not like it can improve my brain anytime soon, it's at least something that will advance research by leaps and bounds. So,
yes.
You love to see it, and hopefully it saves maybe even a mouse or two. So we'll certainly see. So story number 3, very, very cool. Story number 4 is like, when it comes to a lot of our conversations, actually, also, very similar to story number 3, whenever we talk about 3D printing organs, we've had the same issue. And by we, I mean people much smarter than I, because I have done no research or work in this field. But being able to not just print the organ, and Ralph, there's a very traumatic, and I know that we like to leave people feeling happy and all the good stuff on Friday, but there's a traumatic documentary of a doctor who, at the very early stages of stem cells and organ transplants, he actually printed a 3D printed like plastic trachea, and he coated it in stem cells, and he wanted to, and he tried implanting it into people's, where their trachea, through throat cancer or, smoking, like whatever caused them to lose their trachea. Right. And Ralph, like, he was hailed as like this amazing doctor that was saving people's lives. Didn't do really any research, and obviously, like, the immediate, it was pretty, it was pretty astounding stuff, but it lacked any of the blood vessels, any of the ways to get nutrients to these organs. And Ralph, like, bad things happened to the people that got these kind of knee-jerk trachea replacements. And it just really highlighted to me just how how awful it can be if you don't get this right, and how hard it is to get it right, because it's not just like, oh, you slap some cells, you're good to go, and you have an organ. No, very, very different. And story number 3 really tackles this, because it's been an issue as long as I've heard of 3D printing organs.
Yeah.
So, yeah.
Yeah. No, you're right. And our final story for today, and folks, if you're new to the show, Ben and I like to end these Friday segments on technology and trends and so forth with something from the medical field. And it's rather closely related, frankly, to the previous story about the brain tissue. And so it's a nice kind of complement to that, because it does address what Ben's talking about. One of the biggest challenges is, how do you keep these lab-grown organs or tissue alive? It's one thing to create it, but how do you keep it alive? Because, friends, our bodies are a miracle of a network of incredible arteries, vessels, capillaries, the whole 9 yards, right? So let's get into the story. This comes from newscientist.com. Headline: blood vessels made with 3D printed ice could improve lab-grown organs. Subhead: molds of an organ's delicate blood vessel network can be made with 3D printed ice, helping to overcome the intricacies of growing transplant organs in a lab. Wow, another another mind blower. So here we go. First, let's set the stage by outlining the challenge that underscores the significance of this news. First, researchers have been working on artificial organs, as we know, for decades to help meet the high global demand for transplants, such as hearts, kidneys, and livers. But creating the blood vessel networks needed to keep them alive is still a challenge. That's what we were just talking about. Now, existing techniques can, for example, grow artificial skin or ears, but any flesh or organ material dies off if the tissue is more than 200 micrometers away from a blood vessel. That's about twice the width of a human hair.
Not
so
far.
If you're twice the width of a human hair from a blood vessel, lights are out. That tissue lab-grown is not going to make it. Now, lab-grown internal organs therefore require new processes to create delicate blood vessels if they are to become less expensive and faster to manufacture. Okay, so there's the setup. That's the problem. Here comes the news. Here's how the Carnegie Mellon University in Pennsylvania, another Pennsylvania, this is a big one for you guys this week. Pennsylvania is really hitting it out of the park. So here's how the Carnegie Mellon University in Pennsylvania researchers, headed by Philip Leduc, that's Leduc, have figured out a way to solve this blood vessel networks challenge to help create complex artificial organs. Here we go. Here's what they did. First, they 3D printed a mold of veins, arteries, and capillaries in ice. Next, they cast that mold in organic material and then allowed the ice to melt away, resulting in a delicate, hollow network or a mold. This leaves the space for the intricate artificial blood vessels that are required to develop lab-grown internal organs. Now, the article gets into how they got to this discovery, and it's kind of a fun story. Previously, Leduc and his colleagues, which included students as well, by the way, experimented with printing blood vessels with wax that can be melted. But as you can imagine, this requires reasonably high temperatures and can leave residue. So they thought, that's not going to work. And then Leduc, the lead scientist on this, recalls, quote, all of a sudden, one day, my student goes, hey, why don't we just use water, the most biologically compatible material in the world? And Leduc said, and I'm like, oh yeah, it still makes me laugh. It's just so straightforward. So it was a student who said, wait a minute, time out. This wax stuff ain't working. Let's try something like water.
No, it makes sense that, if you're trying to do something new, you try to find a metamaterial, or in their case, like a wax, like something can be used. But I guess water just wasn't his first thought. And, it just took an outside voice to say, hey, what about? And there you go.
Yeah, I love it. It's a great example of how research can happen. It can be that moment when the light bulb goes off and you come up with an entirely different new idea. So They developed a technique that uses 3D printers to create a mold of the interior of an organ's blood vessels in ice. In tests, these were then embedded in a gelatine material that hardens when exposed to ultraviolet light before the ice melted away. The team used a platform, get a load of this, cooled to minus 35 degrees Celsius. That's minus 95 degrees Fahrenheit. Brr. And a printer nozzle that dispensed hundreds of drops of water a second, allowing structures as small as 50 micrometers across to be printed. Wow.
Yeah.
Leduc says the process is conceptually simple, but needs to be tuned perfectly. If you dispense drops too fast and they don't freeze quickly enough, it will fail to create the desired shape. But print them too slowly and they just form lumps. So they had big challenges here. The system is also affected by weather and humidity. So the researchers are investigating using artificial intelligence to keep the printer tuned to varying conditions. Another great example of the use of artificial intelligence. It's everywhere all the time. It's like that movie. What is it? Everything all the time, all at once.
Yes. I'm honestly surprised that as scientists, they aren't just like, oh, let's just create a way to control these parameters. But I guess if you want like a more accessible kind of technology, you can't just say, oh, you have to build this entire room dedicated to this one little 3D printer. No, they're trying to make it more compatible with more areas. So that makes sense.
Yeah, yeah. And I'm reminded too, in the show notes, come out to computeramerica.com. If you're listening to us as a podcast, come out and get the show notes because we have a great little picture of one of their ice molds of a artery. Or a vein. It's just amazing, just amazing. Well, here, to go on here to conclude, they also used a version of water in which the hydrogen is replaced by deuterium, a stable isotope of the element. This so-called heavy water has a higher freezing point and helps to create a smooth structure by avoiding unwanted crystallization. And tests have shown it will be safe when creating artificial organs, as deuterium isn't radioactive, unlike some isotopes. Leduc, the lead scientist, commented it. So, wow, amazing, amazing stuff.
Something that I had no idea that they were making any kind of headway on. I thought it was just one of those issues that, was just too complex to really tackle right now. But the picture, I think, for the article, which may be the thumbnail for the whole show, really is just revolutionary. Just how
it sure is
fine it is. It's almost snowflake-esque. It's very very
That's
highly
a good
detailed
comparison. Delicate, very, very delicate.
Very delicate.
And what a process to control this. Wow.
Yeah, no, goes over my head. But, ladies and gentlemen, if you are following along, you may notice that's the end of story number 4. But there's more. And Ralph, as we like to say, these are not stories that are not worthy. It's stories that we just don't have time for. So let's go ahead and mention the honorable mentions.
Yes, so we got a few of those for you for homework if you want to come out and get the show notes and check these out. First story is Holy Grail for Memory Technology. New candidate for universal memory emerges in race to replace RAM and NAND. And this one doesn't use a toxic compound. So this comes from Tech Radar. Great story. Very geeky. If you want to geek out, check it out. Next one is, this is a little more human. Headline, Yamaha just unveiled the world's first hydrogen outboard motor for boats.
Neat.
Comes from wonderfulengineering.com, a great resource. Check that out if you're a boat enthusiast. They're trying to get hydrogen into the water, so to speak, and more every day. Next one, this is hilarious. This is so hilarious, but also serious. This baby with a head camera helped teach an AI system how kids learn language. This, of course, is so geeky. No surprise, coming from MIT Technology Review, a fascinating story, kind of bizarre, but very interesting. And then the last one, this news just broke this week. Microsoft will use Intel to manufacture homegrown processors. And we're talking about Intel earlier in the show, Ben, and salute to them for Pat Gelsinger for really kind of breathing new life into the corporation. One of the things Pat has done is spearheaded this idea of get over yourself, Intel. We can also be a foundry for other people. We can have a side business of making chips for other people, making customized chips or general purpose chips. We can compete with the big people in Asia who are doing this day after day after day. And so this is a great example of this, where Microsoft is shaking hands with Intel and Pat Gelsinger and saying, you can develop the chips for our future Surface products and so on. So great story. Check that out as well. A good trend. They're indicator of where that company's going.
Yeah, no, they're all great stories. And I always give credit to Intel for one thing, which is, a lot of other companies either went out of business or they moved their processing and sold it to Taiwan Semiconductors, or they sold it to Samsung or whatever. Like, there are other chip manufacturers out there, but they all moved, and they're all concentrated in Taiwan, which is definitely not in the headlines for any reason whatsoever. They're either in Taiwan, they're in South Korea. Like, these chips are really centralized in one place, and that's a problem. Right. Like, it would be nice if there was one in Europe, if there was one in the US, if there was one in South America, if there was one in the Middle East. Like, it'd be nice if you had more distribution. And Intel, I always felt like, being Computer America, we're kind of, we like America. America's a pretty cool place. And to know that Intel is really, kind of pushing for keeping things manufactured here in America has always been, I guess, like a point of pride when talking about them. So
absolutely.
So I definitely appreciate that. And with that being said, ladies and gentlemen, these have all been great stories. We appreciate you so much for, really tuning in, listening, and sticking through the technical difficulties that are completely not my fault. And Ralph, I have made it a point to never mention our internet provider that we use here for the show. And that's for a reason. It's because they are the worst company, but I've never said it, so it could be anyone. Who knows? With that being said, everyone, thank you for tuning in. Catch us next time. We'll be back, with more Ralph, with more show. Everyone, have a great weekend. Do something fun. Catch you next time. Bye, everyone.